Alright, so here we've got section 14.6 from game theory, which is covering the core of an n-person game. So we're just building off of basically what we just talked about in 14.5 with characteristic functions, and now we're going to define what a core is of an n-person game. So to start things off, we do have a quick definition of domination. And domination is just when all strategies in X can defeat Y, we have X dominating Y. So basically, all this is saying is when X is a 100% better option, it dominates. You know, it's just better than X, or better than Y. So then we get into the core definition here. So the core of an n-person game is just going to be the set of all undominated imputations. So really what that means is the core is just all feasible and optimal solutions or imputations, because obviously you're not going to choose a solution that is dominated. That doesn't make any sense because there's another option that's 100% better for everybody. So why wouldn't you take that better option? So we have our first example here. Consider a three-person game with the following characteristic function. So if we just look at this, we have V of the empty set is equal to player 1 equal to player 2 equal to player 3, which all is just going to be 0. Then we have the coalition of players 1 and 2 is going to give us a reward of 0.1. And then a coalition with players 1 and 3 equals a coalition with players 2 and 3, which equals 0.2. And then we have the coalition of players 1, 2, and 3 equals 1. So now they give us two imputations here. We have imputation X and imputation Y, which again, these are just giving us our rewards for each player 1, 2, and 3. 1, 2, and 3, and then respectively 1, 2, and 3. And they wanted us to show that for players 1 and 3, Y is going to be a greater option than X. That's what this little notation means here, basically, is just for player 1 and player 3, show that Y is greater than X. So let's start off by just kind of writing out these imputations here. We have imputation X is equal to 0.05, 0.90, and 0.05. And then we've got imputation Y is equal to 0.10, 0.80, and 0.10. So now again, we're only looking at players 1 and 3 here and showing that Y is going to be greater than X. So looking at player 1 here, we can see obviously that Y is a better option. And looking for player 3 over here, again, 0.1 is bigger than 0.05. So for players 1 and 3, it's pretty clear that imputation Y is a better option. Now to take this one step further, we can also look at the characteristic function up here for players 1 and 3. If just these two guys team up, they're expecting to make a reward of 0.2. So if you look down here, the sum of, let me switch my color. The sum of these two numbers should be at least this 0.2 that they're guaranteed in the characteristic function. Otherwise, it's not worth it for them. They should not take this team. So that being said, if you look at imputation X here, the sum for player 1 and player 3 is 0.05 plus 0.05, which is 0.1, which is less than that 0.2 that they're guaranteed in the characteristic function. So they should never take imputation x, because they're not getting what they're guaranteed in the characteristic function. And then moving on here, we have the problem for this section, which we're looking at that same garbage problem from the last section. Each of 4 property owners has 1 bag of garbage, must dump it on someone's property. If B bags of garbage are dumped on the coalition of property owners, the coalition receives a reward of negative B. Now we're looking for the core of this game rather than the characteristic function. So we know here that any imputation x is going to be x1, x2, x3, and x4, or the reward for each of these 4 players, is going to satisfy some inequalities. So we know that at worst, a single player can have 3 bags of garbage dumped on them because they're not going to throw it on their own. Each player can have, at worst, 3 bags dumped on them. So what does that translate to? That gives us x1, the reward for x1, has to be greater than or equal to negative 3, the worst case scenario. And the same thing goes for player 2, player 3, and player 4. Now, we also know that there are 4 total bags of garbage in play here in this game. So we know that the sum of all of these rewards is going to have to equal negative 4. Because in total, there are 4 bags of garbage thrown amongst these property owners. So the sum is going to equal the sum of the bags. Now, moving forward here, we can say that an imputation is only in the core if for every coalition S, the total rewards for players in set S is at least as big as the characteristic function for that set. So we're kind of looking back to our characteristic function from the previous section. And again, just kind of like we had in that first example and the definition of the core, if something is not satisfying this condition here, then it's not going to be in the core because it's going to be dominated by another option. So moving forward, if we recall from the previous section, V of the set S is equal to negative 1 when the cardinality of S is going to be 3. When there's 3 members in this coalition, the reward is going to be negative 1. So what this tells us is if we've got players 1, 2, and 3 working together, at worst, they're going to have a score of negative 1. If we have players 1, 3, and 4 working together, they're going to have a score of at worst negative 1. Same with players x2 plus x3 plus x4, at worst negative 1, and then what am I missing here? Oh, just plus x1, x2, and x4, at worst negative 1 here. So now what we're going to do, I'm a little bit out of space here, I'm going to make a white color and just kind of run down, is we're going to sum these equations from right above here. Can't really write up there. So what that's going to give us is x1 plus x2 plus x3 plus x1 plus x3 plus x4 plus x2 plus x3 plus x4 plus again x1 plus x2 plus x4, and all of this is going to be greater than or equal to the sum of all those negative ones, or negative 4. So rewriting this equation, we have 1, 2, 3 x1s, 1, 2, 3 x2s, 1, 2, 3 x3s, and 1, 2, 3 x4s. Or in other words, we have 3 times x1 plus x2 plus x3 plus x4 is going to be greater than or equal to negative 4. Now, here's where we have an issue here, and this is going to help us get to the solution of our core. Is remember up here we had x1 plus x2 plus x3 plus x4 has to be equal to negative 4, we know. So we can come down and plug that in, and now we've got 3 times, we know this sum has to be negative 4. It's going to be greater than or equal to negative 4. But in no case is negative 12 ever going to be greater than or equal to negative 4. So therefore, we have an empty core, because there are no situations in which our solution is going to dominate for everybody. Everyone is always going to have a better alternative, so therefore the core of the game is empty. There's no guaranteed solution here. And that wraps up section 14.6. Thanks.